Now, this question is very interesting. We need to prove that triangle AXB is equal in area to triangle AYC. AXB is equal in area to triangle AYC. Now here in your support, we will do some construction, and in your support will come two more triangles. I am just giving little time. Those who got it, great. For others, giving little time to get those two triangles. Now, I believe this question can be done without any construction. Right away, we can do this question. But then, let's see. We need to use the same theorem thrice. First construction, join X and C. And next construction is join B and Y. Now, we have got how many triangles? Now, we need to locate the triangles. We have triangle number 1, that is triangle AXB. AXB. I'll shade this triangle. This is triangle AXB. Then, second triangle to our rescue is triangle XBC. Triangle XBC. Now, triangle XBC, we can just name it as the dotted triangle. Then, the third triangle is the triangle BCY. BCY, let's make this triangle, let's say we'll have another shaded triangle, and finally fourth triangle I'm leaving it blank, that's triangle AYC. It's a very direct question. First, have a look at this. Triangle AXB, triangle AXB is equal in area to triangle XBC. They have the same base XB and lie between the same two parallels. So now the next triangle comes to play, that is triangle XBC. This triangle XBC is equal in area to triangle BCY. BCY. They have the same base BC and they are also lying between the same parallels XY and BC. You have to think of this. Finally, now the whole thing has shifted to triangle BCY. Now, from here we connect to this. Now BCY will come into play. Triangle BCY is equal to triangle ACY. That's correct. Triangle ACY. This. They have the same base CY and lie between the same parallels. So this triangle BCY and ACY are equal in area. So now we connect triangle first to second, second to third, third to fourth, and we can say therefore with this connection we can say triangle AXB is equal to triangle ACY. Now, how do we do the same question without construction? Alright, we don't bring the triangles. We say triangle AXB is half of parallelogram XBCQ. Parallelogram XBCQ. Then we say parallelogram XBCQ is equal to parallelogram PBCY, because again they have the same base and lie between the same parallels. So XBCQ and PBCY have the same base and lie between the same two parallels. Now this triangle AYC is half of the second parallelogram PBCY. So we can connect this triangle half of this parallelogram XQCB. XQCB equal to PBCY and AYC half of PBCY. Therefore, these two are equal. That's the second method of doing this question. Okay.